Hi everyone, welcome to section 6.4. We're just going to do a quick walkthrough of a couple key points. I hope this is useful and helps you get past those points where students tend to get stuck. First of all, we're going to have 4 different types of variation here: direct, inverse, joint, and combined. Pay attention because I'm going to give you a couple little tips to kind of help you break these types of problems down. We're basically talking, by the way, about any type of an equation where you've got one variable, like x, somehow related to other variables, k, y, w, v, whatever, through the operations of multiplying or dividing or both. If you have a direct variation, like y equals 4 times x, either the two variables are both increasing or the two variables are both decreasing. If you have something like y equals 4 times x, let's say x is a special type of pen I want to buy, and every pack of them costs $4. So if I buy 1 pack, I would pay $4. If I buy 2 packs, I pay $8. If I buy 3 packs, I pay $12. Y equals 4 times x is a direct variation. Both values are increasing or both values are decreasing. Like if x goes up, y goes up. If x goes down, the number of packs of pens I buy, then I spend less money. That kind of makes sense. So again, something like y equals 4 times x is an example of direct variation. The 4 is what we call the constant of proportionality. In other words, what's the ratio or the variation constant acting on the x? Here's an example from physics. So for example, it says the length that a spring will stretch varies directly with the force attached to the spring. So that means we have an equation like S equals K times F. The way I know it's that is because it says it varies directly. As soon as you see varies directly, you think, oh, y equals K times X. Then you're going to put the values in. So this particular one says, what's the equation if the constant was 0.07? So that means K is going to be 0.07. There's another example here where you have a movie projector, and you know the old-time movie projectors from the back of the theater. You know, what's the area of the projected picture when you're at a certain distance? Okay, area equals K times D, the distance squared. It's a direct relationship. So y equals K times X, in this case, X squared. So we put the values we're given in, initially 100 equals K times 25, the distance squared, so that we can solve for K. Now we know that magic proportionality, and so we can combine it in another problem to find out what's the area. So if the distance became 40, then the area is 256. Remember, the order of operations is such that you're going to square the 40 before you multiply by 0.16. Inverse variation means that as one thing goes up, the other thing goes down, or vice versa. So you're going to have an equation which looks like this: y equals k over x. If you look at this, you can see how if I had, for example, y equals 1 over x even, there's a big difference between saying y equals 1 over 10 versus y equals 1 over 100 versus y equals 1 over 1,000. The smaller the value of x, the bigger the value of y. The larger the value of x, the smaller the value of y. They're inversely related. And there's an example here with a speaker loudness. Inversely, as soon as I see inversely, I have to think y equals k over x. In this particular case, y equals k over x squared, or d squared. If you're following along with this, and you can always pause the video and write these down, but this is the equation you're going to be looking at. In this particular case, the loudness L is equal to k over d squared. L equals k over d squared. As soon as it says varies inversely, I have to have a fraction there. Then I'm going to plug in the numbers that they gave me originally to solve for my, quote, magic proportion k, you know, my variation constant there. The third one is joint variation. Joint variation means you've got a variable that's varying directly as a product of 2 or more other things. In other words, there's 2 variables playing a role. For example, I might say y equals 2 times x times z, or y equals k times x times z. And k, again, is our constant of proportionality. So you might say, when would that happen? So the example here would be thinking about the area of a triangle. If you were actually constructing perhaps a triangular flower bed at the corner of a building, you can change the base of the triangle and you can change the height of the triangle. And so if you're changing both of them, they both have an effect on the overall area. So again, you have A equals KBH. You plug in the numbers you're given, and now we have a proportionality constant of 1/2 for K. And then you can plug it in to find the area that you would have if your base were 15 and the height were 20. Okay. The final one is called a combined variation. This is a very common thing in real life. So you've got one variable kind of varying as some combination of variables. So for example, engineering, the load that a beam can support depends on the width of the beam, the square of the depth of the beam, the length of the beam, and of course that proportionality constant. I have old beams in my kitchen. We'd have to be careful. They're open, it's an open kitchen concept, but if there were a floor above there, we would have to be cognizant of the weight because the beam can support that weight based on its length, width, and depth. So this particular ratio here is L equals K W D squared over I. And here's an example with something very different, like a hot dog price. Obviously, if you're going to sell something to tourists, for example, you've got advertising budget, you've got your weekly sales, you have your price of your raw product, in this case, the hot dogs, then we know there are a lot of different factors affecting this, right? So we're trying to, first of all, find a general equation, and then we're trying to find expected sales. So S equals K times A over P. And so we have a proportionality constant. So the equation is for the weekly sales in general, S equals 14A over P. Now, if I go back to my original problem just for a moment, it said find the expected sales if my advertising budget was $800 and my hot dog price was $1.75. So now I'm going to go in here and plug in that $800 advertising and the price of $1.75 to find my weekly sales would be $6,400. Okay.